So thermal expansion, as you may know, metal, most solids, but metals in particular, expand when they get warmer and contract when they get colder. So that's very important in engineering. As you can see, this is a railroad in India where the tracks, the segments of the rail, the sections of the rail were laid too close together, so there was no room for expansion. The rail buckles, the train derails. Same in steel beam buildings. You have to take into account the expansion of the metals. The reason that metals expand is that metals, like any other material, are made out of atoms. And atoms get further away from each other when the temperature goes up. So this is a cold metal, and this is a hot metal. Cold, hot. You're smiling, but it's true. Now, you may wonder, this is actually the only thing I'm going to test, but you may wonder, why are they getting further away from each other? Well, the reason is that what we call temperature has to do with the thermal motion of atoms. Atoms don't sit still, they shake back and forth, and the amplitude of that motion is what we call temperature. So this is these are cold atoms, these are hot atoms, right? As you can imagine, if you move over a bigger amplitude, you need more space. So as they need more space, they move apart. It's an internal form of energy, if you want. Questions, anybody? I knew I gave very clear lectures. Look, it's not just those 9, right? Cold, hot. It's all of them, all millions of billions of atoms inside the material. No questions? Look, I'm not going to... See, one of the things I could do is make the screen black and then ask you the question, when metals heat up, they expand because the atoms A get closer together, B stay the same distance apart, C get further apart. But that would be simply me giving information to you and you regurgitating that same information back to me. I'm going to see if you have really understood this picture of atoms getting further apart and can transfer it to a new context. Are you ready? Yeah? No questions? Wow. Okay. So, here's the question. Consider a rectangular metal plate with a circular hole in it. Okay, and there's not going to be any talking, right? You first work on it individually. If you start talking, I run to you with the microphone and you're going to have to talk in front of everybody. All right? All right. When the plate is uniformly heated, the diameter of the hole, 1, increases. 2, stays the same. 3, decrease. What? 20 people have already answered. Have you thought about this? Please, think. Think about atoms getting further away from one another, okay? So take your time and then enter your answer. So let me tell you a little bit what we're going to do next. What I'm going to ask you to do, I'm going to give you a little bit more time in just a second, but I want you to turn to a neighbor and first say which answer you've given. And if your neighbor has given the same, no, stop, wait a second, you get a chance in just a second. If your neighbor gave the same answer, you say thank you very much, and you turn to your other side or front or back. And if everybody around you has the same answer, you get up and walk around in the lecture hall. It's no problem. But you have to talk to somebody who has a different answer. Once you've convinced that person, or that person has convinced you, don't just sit there still, because I'm going to come right at you, right? Continue the game. Try to convince somebody else. So go ahead. Find somebody else and start discussing it. What happened here was that, one, you made a commitment, right? I had you press on a button, or, with a clicker, or in this case, press on a button on the screen, or maybe you mentally wrote down an answer or committed to an answer, but you made a commitment. After you made a commitment, you had to externalize your answer. You turned to a neighbor and you said, I chose because blah, blah, blah. And the discussion turned from answer or fact to reasoning. Right? Your discussion, you actually got beyond the answer or just the fact. But most importantly, you became emotionally invested. You're all dying to know what the answer is. I mean, imagine I'd just given a lecture, the little lecture I'd given on the expansion, and I said, if we take a metal plate with a circular hole in it, and we put the plate in the oven, and we take it out, the diameter of the hole will, I'm going to keep you in suspense a little bit longer, but you would not have had this level of engagement. You'd be sitting, maybe taking notes, but there would not have been this eagerness to wanting to understand it. I mean, come on, this is just a metal hole with a metal plate with a hole in it. It's number one. Oh. Now look at that, I'm sure you have again forgotten that I'm here to talk about education, not about thermal expansion. Listen, I don't want to be responsible for you lying in bed tonight thinking, imagine you have a jar of marmalade in the refrigerator. You can't take off the lid. The lid is a ring with a metal plate on top. What do? You run the metal lid under hot water so that the ring expands. You say, that's unfair. It's a ring. This was a plate. Okay, imagine we take a metal plate without a hole in it. We draw a circle on it. Now we put the plate with the circle in the oven. It expands. What happened to the diameter of the circle? Has to get bigger, right? Everything bigger. It scales up, so the circle will get bigger too. You say, that's unfair. There's no hole. If there was a hole, then the atoms would expand into the hole. Well, let's think about that for a moment. Imagine the atoms at the edge of the hole. We form a big circle. We go outside, form a huge circle. We are the atoms at the edge of the hole. Now we walk in towards the center of the circle. What just happened to the distance between us? Got smaller. Can't get smaller. Remember, the neighbor is shaking more. The only way to make the distance between us larger is to move out. You won't forget this. So in conclusion, education is not just about transferring information, which is what we mostly focus on, or getting students to do what we do. I want my students to stand on my shoulders, to solve the problems I cannot solve. We want the next generation of students to solve the problems that this generation, we have not yet solved. And teaching by telling will never get them to that spot. I think active participation is an absolute must.